Hello everyone, my name is Sojan Matthew and today I will be demonstrating the partition tolerance of NoSQL databases. To do so, I have chosen AP and the CP system. For an AP system, availability takes precedence over consistency, and for a CP system, consistency takes precedence over availability. I have chosen MongoDB as a CP system and ReactDB as an AP system. So let's start with the MongoDB architecture. This is my architecture where I have 5 Mongo nodes running in the private subnet and a jump box which is in the public subnet. So I will be accessing all the nodes through via jump box, and this is the VPC that I have created for the demonstration, and which has it has 3 subnets, 2 private and 1 public, and these are the security groups that I have associated with the cluster. My Mongo clusters have been associated with the security group where I have opened the port 22 and 27017, which is the default port of MongoDB, and my jump box is in a public subnet which has ports 80, 22, and 443. Now coming to my instances, these are my 5 instances, 1 primary and 4 secondary, all in the private subnet. Secondary 1, secondary 2, secondary 3, and secondary 4, and a jump box which is in the public subnet. So let's start with the demonstration. I am logged into all my nodes, 1 primary and 4 secondary. I already have some sample data inserted beforehand. Let's check the data. So I have 4 documents right now. Now I'll read, in order to read from secondary, I have to do a rs.slave OK and switch to personal project DB and do a find. So as we can see, the data is being consistent across all the nodes. Yeah, so this is the data from the secondary nodes. So this is the, now I'll try to insert a new data from the primary and see the behavior in the normal mode. So inserting a new document in the collection from primary. Now when I do a find, I can see the data being inserted. Now and do a find on secondary, we can see the data being consistent across all the nodes. So this is the behavior when the system is in healthy state and all the nodes are functional. Now I'll try to create a partition. To do so, I will be using a iptables drop method, which will block the traffic from all the other nodes. So I will be doing the partition on secondary 3 node. So I will execute the following commands on the secondary 3 node. Now let's log in back to the Mongo shell from secondary 3. Now I'll do rs.status from secondary 3. It should show all the nodes to be unhealthy and not reachable. So now this node is in the partitioned network. Now when I try to insert a new data on primary, we'll see the behavior. So now I'll try to insert a new data. This is being inserted. Now do a find on the primary, shows me the documents being inserted. Now doing the same across the nodes. Now I can see the data is being consistent. But when I check the secondary 3 node, which is being partitioned, we can see the data being stale, and there's a stale data there. It's not updated across the secondary 3 node, which is being partitioned from the other nodes. Now when I do a find from the final node, it is being reflected. So as we can see, the data is not being updated in the secondary 3 node. Now let's try to recover the partition. Now I have recovered the partition. Now let's log in back to the Mongo shell. Now when I do rs.status, now I can see the nodes being healthy and now they are reachable. Now let's check the data in the secondary node using rs.slave OK. Switching back to DB and now do a find. Now we can see the data being updated across the nodes. Okay, so now let's see what happens when the primary node goes down. In order to do that, I will be blocking the traffic from secondary nodes to the primary. So let's try to create a firewall blocking on the primary node. So executing these commands, now this will create a firewall block on the primary node. Now let's check to see if the, yeah, now we can see that the primary has switched to secondary as it has been disconnected from the other nodes. Now there will be a new leader election among the live nodes. Yeah, so now we can see that a new primary has been elected. So MongoDB follows the leader election policy. Whenever a primary node goes down, a new leader is elected among the live nodes based on the highest uptime. Okay, so now let's test the effects of partition on an AP system. For that, I have chosen a React DB with the following architecture. I have a jump box configured in a public subnet and 5 different React nodes in 2 different private subnets. Now these are my instances running in the private subnet React nodes 5, 4, 3, 2, and 1, and a jump box which is configured in the public subnet. The security groups of React nodes are as follows. These are the port mappings that I have exposed to, and these ports can be found on the React documentation where they have provided the default ports which React nodes need to be configured. Now let's log into this nodes. Now I am already logged into my 5 React nodes and I have formed a cluster. Now to check the cluster status, I will execute the cluster status command. Now as we can see, all the nodes are up and running. I'll do the same from the other nodes as well. Yes, so as we can see, all the 5 nodes are up. Now let's try to insert some data on the node. Now doing a write operation on one of the nodes. Now let's see if it is getting reflected across the nodes. So as we can see, the data is being replicated across the nodes. Yeah. So unlike MongoDB, which follows a master slave architecture where all the writes and reads are on the primary database, in the React database, reads and write can be done on any of the nodes. So now I will try to write from the second node, doing a write on the second node this time. Yeah, now let's try to read the data from the other nodes. Yeah, so as we can see, the data is being reflected across the nodes. And now let's try to introduce a partition between the nodes in the different subnets. So I will be creating a partition using the IP tables drop method. So let's create a partition in the nodes in the second subnet. So I will be executing the commands on both the nodes. Okay, so now let's check the cluster status after the partition. So as we can see, the nodes in the other subnet are down from the and unreachable from the first subnet. And doing a cluster status from the second subnet, we can see the first 3 nodes are unreachable. So now as a result, we have successfully created a partition. Now let's try to insert some data in the partition mode. Now I'll be inserting a value of key 3 in the first subnet, one of the nodes in the first subnet. Now let's check the values of the key 3. So yeah, we can see that the nodes in the first subnet will be sharing the updated value. Now when I do a curl to get the value of key 3 in the second subnet, I can see the data is not consistent. There is some old value. Now I'll try to insert the key 3 in the second subnet as well with a different value. Yeah. Now when I do a curl command on the second subnet, one of the nodes. Now when I do a curl command on one of the nodes in the second subnet, I can see that the last value is being reflected, but the first node still has the old value. So now let's try to see what happens when the partition is recovered and which value gets preserved. So now I'll be recovering the partition. Yeah, now let's check the cluster status. Yeah, now as we can see, the cluster is back up and all the nodes are functional now. Yeah, all the nodes can be seen as reachable and up. Yeah, now let's check which value of key 3 is being preserved across the nodes. So now when I check the value, we can see that the value that was returned at last gets reflected across all the nodes. So as a result, now we can see that the last key that was returned is being updated across all the nodes. Now React follows a last write wins policy, in which the data that gets returned at last will be reflected across all the nodes and the previous data might get lost. So here the availability takes precedence over consistency.